Okay, so let us continue the discussion on the engine hardware part, and we have already seen the piston and the piston assembly. So today I have actually brought a piston cylinder, piston and a connecting rod here to show you. This is an actual piston and the connecting rod. You can see the connecting rod here of an automobile engine. So we are focusing on closely to this piston and connecting rod assembly. You can see that there are two connecting rod bolts. This is the lower half of the connecting rod, and the bearing is inside. Here you can see the bearing of the lower half. The upper half bearing is here, okay, and this is a connecting rod. You can see this makes a wobbling action as the piston goes up and down like that, okay. And here is the piston. You can see the piston, you can see the guzzon pin. The pin has gone inside this, and you can see the bearing at the bottom. You can see the bearing at the bottom here, which you can see how the connecting rod is fitted into it. And you can also see piston rings. You can see two piston rings, two on the top here, and there is a different design of the piston ring which is at the bottom here. You can see there are three piston rings. So the upper two are essentially used for, as I was telling you in the last lectures, the upper two is used for the sealing of the gas inside the combustion chamber, and the lower one is called as a lubrication. It is used for lubrication. So it is used to spread the lubricating oil as the piston moves up and down, okay. This is used as a oil scraper ring. It produces a lubricating oil film inside the cylinder liner, between the cylinder liner and this ring, and which essentially reduces the wear and reduces the frictional let's say the frictional force between the two mating components, that is the piston ring and the cylinder liner at the side of this. On the top you see the piston, the crown of the piston, and you can see the small depression here on the top. So we will have when we study the gas exchange process in the combustion chamber, at that time we will study more about the design of why this design is, and what is the importance of these depressions or these special shapes which you can see in a piston cylinder, in a piston connecting rod assembly. So I thought I will bring this actual one from a small automobile and show it to you. As you can see, this is aluminum. This is aluminum piston, okay, made of aluminum, and this is usually pressure die casted, the connecting rod. So this is the total assembly of the piston and the connecting rod. Now, so let us move on to the to actual seeing some photographs also. So for example, here this is what the assembly I just showed you, and here is how it gets fitted inside the engine. Now looking at the connecting rod, for example, several shapes. You have seen one of these shapes which is very similar to the diagram here. For example, these are different views. This is the lower half of the bearing, this is the upper half of the bearing, and this is the connecting rod. Now you can see on the right, I have created a picture here of a very large connecting rod. So when we say this typically is for a very big engine, typically for a marine engine, for example, or a very large generator, typically for marine applications. So this is a very large, let's say, connecting rod, and you can see it is almost double the height of a typical person. You can also see the two bearings, which will actually go one on the top half here and the other one will go to the bottom half. You can see some holes in it. These holes are also there, the matching holes are there in the connecting rod. These are for the oil to sort of come and lubricate the crankshaft, which will be connected in this particular, the bottom half of the connecting rod. So this is a very typical let's say shape of the connecting rod. Then this connecting rod essentially goes and gets fitted into a crankshaft. So you can see a crankshaft here of a multi-cylinder engine. So there may be 4 cylinders, for example, and this particular connecting rod, as you can see, comes and gets fitted into the lower half, the bigger half of the connecting rod, so to say. It gets connected to the crankshaft at the bottom here, and you can see the complete assembly here. Naturally, this is the one where the power train, the power of the engine comes out. Usually there is a flywheel and the gearbox which will be connected at one end of this system, and there will be two bearings, one bearing on this side and the other bearing on the other side there, on which let us say this particular crankshaft is resting, there may be bearings in between also, if the cylinders number of cylinders are large, for example. So this is a complete assembly of the piston, the connecting rod and the crankshaft. In this particular engine there are 8 cylinders, in this engine there are 4 cylinders. This is a small engine of a small automobile, and you can see there are only 2 cylinders or 2 pistons, the 2 connecting rods, each one going to 1 piston here, and this is the overall exploded view or the photograph of this particular assembly. Then, as I was telling you, you can have very large marine engines. So these marine engines, for example, here you see a very large crankshaft, okay, being manufactured in a shipbuilding factory. So the crankshaft can be as small for small engines, let us say for grass, and cutting the grass you have small 2-stroke engines. You can have very small connecting rods of the order of let us say 70, 80, 90 millimeters, 100 millimeters, and then you can really have very large crankshafts here which are typically in meters. The length scale is in meters for very large marine engines. So this is the assembly now. So now the crankshaft has gone inside the engine, you can see here, and you have multiple bearings on which the crankshaft is supported, and this crankshaft has a flywheel on the other side for balancing purpose. You will study that in your kinematics of machines and dynamics of machines, essentially why these flywheels are needed for balancing, because it is a rotating mechanism. So we need to balance the engine so that the vibrational loads are minimum. So essentially we use these flywheels to store that energy and to do balancing. And you can see the power train, you can see the sprockets for the chain drive here at the end. So essentially the connecting rod will be fitted to each of these crankshaft, let us say crankshafts. The bigger end, the larger end, so to say, that means the larger end, this is the larger end, this larger end will get fitted into the crankshaft, and multiple, if there are multiple, let us say units, they will all go in a different phases. Some of them will be on this phase, some of them will be on this phase, some of them will be on this phase. We will discuss that in detail as we go along, that how do we determine the location of these connecting rods inside on the crankshaft. And then this complete assembly will, what you see here, it has now come into the block of the engine on which it is fitted. So this is a typical crankshaft. Okay. Then we have also discussed that how 4-stroke engines require, let us say, or even some 2-stroke engines requires valves. For example, large marine engine, the video which you saw in the initial lectures, it required an exhaust valve which was operated by a hydraulic mechanism. So there are valves which are required for 4-stroke engines, of course, and some 2-stroke engines will also require some exhaust valves or inlet valves. So those valves are operated, they have to be timed. That means at a certain time, depending on the location of the piston, you need to do the 4 thermodynamic processes. So you want to take the gas in or the mixture in, you then have to compress, and then you have to exhaust. So these valves have to be opened with respect to the position of the piston in the stroke in which we are interested in. So if it is an inlet stroke, then the inlet valve is open, and then the exhaust valve is closed, the piston goes down, let us say in a 4-stroke engine, and the air is sucked in, or the air mixture with the fuel is sucked inside the cylinder, inside the combustion chamber. When you are doing a compression stroke, that means you are just compressing the air fuel mixture or the air or only air in terms of diesel engine, for example. In that case, both the valves are closed. So this opening and closing of the valve is actually done by a timing mechanism, a timing gear, and that is, here you see the cam. Okay. So this cam essentially rotates. So this is the cam shaft, and for every cylinder in a multi-cylinder engine, you may have one cam for the exhaust valve, one cam for the inlet valve. There may be multiple valves which are being operated, so you need multiple cam operation for these individual valves. So you can see a very typical automobile camshaft, and then as this rotates, here is a close-up photograph. Naturally they operate at high speeds continuously, and you need to do a proper heat treatment of these surfaces so that there is no wear and tear, because as soon as there is wear and tear in the camshaft, then the opening and the closing of the valves will be hampered, or it will get disturbed, or the timing will not be maintained properly, and therefore there will be degradation in the engine performance, as we will see as we go on. So this particular camshaft is timed. You can see the timing gear. There is a chain or sprocket arrangement or a gear arrangement by which this particular camshaft rotates, and as it rotates it pushes the valves. Okay, and here you can see the video of how the camshaft is rotating and it is pushing these valves for opening and closing. I have with me a typical exhaust valve also. You can see I have brought a typical exhaust valve for you, and you can see this is inside the combustion chamber. This is the seat of the valve. The valve sits here, and essentially you need to maintain a very good metal to metal contact here, because you cannot use a rubber seal or a deformable seal to seal the combustion chamber. So when there is an explosion taking place inside the combustion chamber, both the valves are closed and it goes to very high pressures inside. So to maintain that pressure so that there are no leakages from inside the combustion chamber to outside, you need to have metal to metal seals. So this is the seat of the valve. You can see the seat of the valve here, and then this is called as a stem, the valve stem, and this is the position where the camshaft will actually push this particular valve, and it will go up and down and it will open and close. Okay, so I have couple of valves here for you to see, and the video which you are just seeing on the PPT, it tells you how a camshaft operates, and this is essentially timed with the crankshaft through a timing gear, so that they open and close at the designated period of time and at a designated location, or the with respect to the piston position or the stroke of the piston where the piston is at that moment of time. So this is a camshaft. Moving on, this is a very big camshaft. You can see the timing gear already attached here, and there is a man standing here which tells you the relative let us say size of this huge camshaft. These are again typically for a marine engine. For marine engine operation, you require it's an inline arrangement, and there are many cylinders which are being let us say catered by this particular camshaft, and for every cylinder you have two camshafts operating the two valves, for example, of a large marine engine. So here you can see the dimensions of the camshaft, which are rather huge as compared to small camshafts which are there in smaller engines or smaller automobiles. Then what you have is the place where the piston actually goes inside the cylinder. So the cylinder covers the piston, and as I had made the drawing in one of these lectures, you have seen that this forms the combustion chamber on the top. Okay, so you can see the cylinder liners here. You can see several different types of cylinder liners, and you can see some pistons which will go inside these cylinder liners. So here you see a typical cylinder liner, and this piston with the you can see the slots for piston rings. So the piston rings will be inserted here, the oil rings will be inserted here. You can see some small holes for the oil to come out. So oil rings will be inserted here, the connecting rod will go here, and this particular assembly will be now pushed inside this cylinder liner, and essentially the piston will go reciprocating motion inside this liner. The idea of the liner is that first of all, between the liner and the block, you can also see outside here, you can see some slots. These are typically meant for sealings. So there are rubber sealings which are, or O-ring sealings which are going here and here, and essentially water is getting circulated outside this cylinder to cool the cylinder. So we will in one of these lectures afterwards, we will understand when we study engine cooling why this cooling is required, and because a lot of heat is generated and we would like to protect the engine from wear and tear. So some amount of heat has to be, some amount of temperature control is needed to cool the cylinder liner, and essentially the piston rings they touch the cylinder liner wall, and the piston goes up and down from here. And here you can see the top view of a 4-cylinder engine, and you can see the piston, crown of the piston, which is very similar to what I have shown here. This is exactly the same piston, very similar to that, and you can see this crown, the top view of this crown is what you can see here, and you can see 4 pistons, one on the top dead center on the very top, and other 3 at different phases with respect to this, and you can see this is the top view of the piston, and the liner, this is the cylinder liner which is around it. So this is called as the cylinder liner, and of course you can have, for small engines you require small cylinder liners, and for large ones you require very large cylinder liners. Some very small engines there may not be a separate liner. This block itself, as you can see here, makes the cylinder liner. So it's an integral part of the block of the engine, that is the lower half of the engine, which is called as the engine block. So this particular cylinder liner is an integral part of the cylinder liner, as you can see in this particular let us say slide. So various shapes and sizes of cylinder liners are available, and now here you see really large, very large cylinder liners, and you can see ports for inlet of the air. So as the piston uncovers, please refer to my earlier lecture when we saw the 2-stroke engine operation. At that time the piston uncovers this port, and as soon as it uncovers, air gushes in the inlet stroke in this particular cylinder liner. So you can see slots for O-rings, so that the cooling can be done in this area, and these are different sizes of cylinder liners which are kept for large marine engines or large generator sets which operate on 2-stroke cycles. For example, they have these ports for air entry inside the engine. This is again just going back. Yeah. So again you see a very large cylinder liner. This is an actual photograph, and you can see the complete cylinder liner here. You can see the ports from which the air will come in when the piston goes down. So when piston uncovers this port, I will explain you in one of the next lectures that how the 2-stroke engine, the air entry or the fluid motion is done in a 2-stroke engine. So at that time, so this is a 2-stroke, this is a typical cylinder liner for a large 2-stroke engine, and you can see the piston which actually goes inside this cylinder liner, and it reciprocates inside, and you can see the piston rod connected to the piston. So this is this particular cylinder liner has been taken out, and you can see the piston also is being taken out from the engine, and this is an actual photograph of a large ship, a marine diesel ship, which operates on 2-stroke diesel engine. So you can see some nice photographs here of an actual ship inside of the ship. Then we come to the cylinder head. Okay, the cylinder head is the portion, the top portion of the top part of the engine. So let me go to the blackboard and explain you. So we essentially, if you see the construction, you have engine block, and then on the top you have the head, the cylinder liner or the cylinder is here, the piston is inside this cylinder. Okay, and so this portion, the top portion is the head, and this is the block. Okay, and then there may be a foundation here. Okay, and then the connecting rod. So this is the connecting rod, this is the crankshaft, and the powertrain comes out, and you have the foundation of the engine. So this particular top portion, and then of course there is cooling water which is being circulated here. So this top portion essentially has the valve arrangement. Okay, and then the timing gear, from the timing gear you have the opening and closing. So you have the camshaft. So in certain designs the camshaft can be here, in certain designs the camshaft can also be on the top, and from here you can operate the inlet and the exhaust valve, for example. So this top portion of the engine is called as the head of the engine, and you can see that cooling water is actually circulated in the passages which are around this cylinder head also and the cylinder block also, and in between, since water should not leak out from from these two connections, there is usually a a cylinder head seal, which will protect, which will allow the water to go in. It will go and cool. It can also cool the top valve area, because the exhaust valve, if this is the exhaust valve, it gets heated up, and therefore you need some cooling here also. So the water may go up to the top, and it may cool these valves, typically the exhaust valve. It can cool the cylinder head and cylinder liner. It can also cool the lower portions of the block, and then come out okay, to the radiator. So this is a typical construction. So let us go back to our PPT, and you can see here, this is the block of the engine, and you can see the complete this thing. You can see the valves, you can see the push rod, the rocker arm, and then there is a retainer spring which will take this valve up after it is pushed down. So you have the inlet and the exhaust valves, and then the piston, you can see here the connecting rod, you can see here the timing gear, and the chain and sprocket mechanisms to operate these camshafts can also be seen. And the top portion is the head, and here is the head which has been removed and kept inverted. So you can see the two valves, the inlet and the exhaust valve, and you can see these small passages where water is flowing inside, and of course the exhaust gas has to come out. So there is an exhaust valve outlet. So every this is 1, 2, 3, 4, 5, 6. It's a 6-cylinder engine. So there will be an exhaust manifold from which part of the exhaust will come on this side and part of the exhaust may go on the other side, and they are and then the inlet air also has to go in. So there are inlet and exhaust ports or passages or manifolds which are connected to this cylinder head, and you can see the top portion of the cylinder head, which actually fits into the cylinder liner, and this will form the mind you, this is an inverted, it's kept inverted, this will form the combustion chamber. So you can see several photographs here. One cylinder head, again the valves have been removed, and you can see after removal of the valve how does it look like, and these are the inlet and the exhaust ports which will be connected to a manifold, and there will be an inlet manifold and an exhaust manifold. We will see some of these in the later lectures, and this is the full complete assembly of a cylinder head. Here again it's another view for you to make it more convenient for you to see. You can see water channels, you can see oil channels for lubrication of the camshaft or the exhaust and the inlet valves which are on the head here. Okay. There is an exhaust manifold, so all these exhaust ports are connected to the manifold. A manifold means a collection of pipes come in and they join at this level, and then this exhaust can go to a catalytic converter, for example, or a muffler which is connected to the engine exhaust. And then on the other side there is a inlet port, okay, the inlet manifold. So the air or an air fuel mixture from the engine or the carburetor or the air will come in from here, either from directly from the atmosphere or from a turbocharger, for example, and it will be then fed to this engine. It's a 4-cylinder engine, and you can see some water temperature sensors are there. There is a thermostat which will control the temperature of the engine and the cooling water, for example, from here, and you can see the exhaust valve and you can see the inlet valve, and it's a petrol engine. So there is a spark plug also which you can see on the top of the cylinder head. So this is a very typical cross section of an automobile cylinder head in this, and this is a photograph of a very large marine engine, the one which you saw the cylinder liner and piston a couple of slides back, and you can see the cylinder head, some 6-cylinder engine, and you can see the head which is tightened. You can see that it is tightened by very large bolts because the pressure generated inside will be enormous. So essentially and this head also has the valves for starting the engine. For example, these large engines are usually started by compressed air, so they have to crank them, you have to crank the engine. So essentially these valves are used for cranking, and they also have, let's say, the diesel injectors because this is a diesel engine, so they will have injector assemblies also on the top of the cylinder head. So this is a typical photograph. We will have more time to discuss. There are some more machinery at the back which you will come to know as we go along in the course. This is essentially a turbocharger, and fresh air actually enters from this and enters the engine from below. We have been talking about the valves, and here are some nice photographs for you to see the valve and valve assemblies. and you can see a very typical exhaust valve which has been worn out, and the seat is also worn out. So after a while you may have to replace the valve, or you may have to do some lapping or some finishing of this particular seat, because otherwise the exhaust gases will start leaking from this particular area, and that is, and then you can also see some corrosion. This is because after the combustion gases come out of this engine, they essentially have a high temperature gases, that is steam, which is formed from the hydrogen which burns, the hydrogen which is inside the petrol, the organic fuel, and then we also have carbon monoxide, carbon dioxide. There are other let us say compounds. Typically a petrol or a diesel is a mixture of about 150 to 200 different compounds, and there are also ammonia, I mean nitrogen based compounds are there. There are other impurities, there is silica waste in it, and silicon oxide. So all that burns, and usually you can see corrosion also taking place. The valve stem also you can see corrosion taking place here, and wear and tear, very high wear and tear taking place on the exhaust valve. So here you can see the assembly. You may have multiple inlet valves, you can see multiple inlet valves, and you can also see multiple exhaust valves. So why one valve is not there and why 4 valves are there for the same purpose, for inlet for example, we will try to study during the gas exchange processes, and trying to see how efficiently you can bring the gas in, how efficiently you can put the exhaust out. So there are several factors, transport phenomena essentially, which determines the geometry of this particular cylinder head, with how many valves to take, what should be the area, where should these valves be placed, and things like that. And you can also see, interestingly, you can see the depressions on the piston, so that this piston can go all the way up, and when the valve opens you can still, or when the valve is sort of the bottom portion of the valve can actually rest here. So you can reduce this volume, and you can reduce the volume of the combustion chamber by creating these depressions, so that this piston can go all the way up. Okay, and you can in this piston also you can actually see a small depression here where this valve can actually sit like that. So this piston can go all the way up, and the valve can actually sit in this small slot here. So this slot essentially serves the purpose of accommodating the valve in this space here like that. Okay, accommodating the valve in this space, and the reasons for this particular let us say depression of why you want to take the piston all the way up and reduce this particular volume is something which is related to thermodynamics and the combustion process, which we will of course take it up as we go ahead. So why do you want this volume to be of a certain dimension? The combustion chamber has to be of a certain dimension, and why do you want to make this piston as close as possible on the top, or how close you can go, and how much reduction you can do in this volume, and how is it related to the type of fuel which you are burning and the thermodynamics of the process. We will definitely talk about it in the later lectures. So this essentially gives you an idea of the construction of the engine. The major parts we have covered, and then of course there are other parts. For example, we have been talking about spark plugs, we have been talking about turbochargers, we have been talking about let us say heat exchangers which are there in the engine, which are needed to cool the engine for example. So this of course we will take it up in the next lecture.